Good morning to you all. So today is the last day. Like I mentioned in the beginning, I will not imagine like how quick. So we were thinking okay. So on the end, we thought let us summarize everything and also focus on there are a lot of failure, like in the last slide we saw some of this failure, and after each failure you will find much better research. I will show you also that. So we see a lot of research after the failure because that will guide us in future. So pretty much the two most important failure I am considering, and will give you again I cannot say that this is the exact cause, but one is like most of the people have agreed, but the other one there are different methods and I will show you which one I like. So let us see. So these are the selected. Why I am saying these are the selected? Because this changes everything. The game changer, you can say that game changer. So last thing happened in 1928. Then in Chile, these are highly fatality, fatalities are more. Then in we already have seen all those. One in Spain, and then the Mount Poly, and then the Brumadinho. 2014 Mount Poly and 2019 Brumadinho. Again in the Chile, there are few failures, and due to seismic liquefaction, the Chile is a highly active seismic area, and the main cause, if you look into that, what the slope you see, can you see that, the slope?
1:2.
2:1 slope. So that's a very high slope for terrains. So that's why right now we have decided to 3:1 slope. So most of these things fail mainly because of the upstream, the slope is high. And during earthquake, they didn't resist the earthquake. So you can see one of the example like before failure and after failure. That's the big one, but once it fails, everything can go. Follow that. And these dams are also, the upper one was 70 meter high, and this one also 40 meter high. Height is not that important, the slope is very important. Okay. This is the Brumadinho failure, which we already have seen before. I show you. I will also show you something like. If you look into Brumadinho, in the left you are seeing that time it was intact. Early January. This happened in January 25th. This is another image. Early February. So you can see that everything is took everything. So it started with a small one, but gradually took everything. I had also slides. I did some work here also. I was seeing different days. Like this whole thing took five or 1 week to happen everything. It doesn't happen immediately. Because that's a progressive. Once once your first failure start, then the next one, because now your slope is different, then it will generate the other failure. It's a progressive failure. And you can see this one also, the image before the failure, how it look like, and you can see these are like more than 5,000 meter. At the end there is a before. At the bottom that blue line is a before, and once it hit the river, you stop. So you can easily see the image. These are the satellite images. Satellite image is very clear, like clearly showing how this whole tailings thing they progressed and they moved along these areas. This is kind of the cross section there in the dam. So you can see so many ridges, like there are like close to 10 ridges. And initially you have a starter dam, but then goes on raising. And these are all showing like first starter dam, then the second raise, then the third, fourth, fifth, sixth, going up to the 10. Again, there is not a consensus. Till now, people have not agreed. Most of the experts, they have not agreed. They are simply called. But this one is the latest one. And initially, the expert, like they had in Brazil, government had an expert committee. They said that is mainly due to the high storm water. Prior to the failure, they found that there was a big storm events, like more rainfall occurred prior to the things. Then the second group also, that's a research group that's come from the university, and they did a lot of work, and they found, yes, it liquefied, definitely everybody agrees, like it's liquefied, but the cause of liquefaction at the time of failure, they were doing some drilling. They were trying to install some piezometers. So they were doing the drilling. And their model show that drilling hit a critical layer there, like a weak zone. And when it hit that weak zone, it triggered the liquefaction and all the failure happened. So that was their thing. But this one, like when I read these things, and I pretty much liked it. So you can see that the cause is there in the beginning, because this happened after 3 years. They stopped because it was closed, and after 3 years of closure this happened. But they are saying during construction it is already there, but it takes time to gradually progress and finally grow. In the beginning they said they had high discharge rate. So that's the first thing we have to make sure. The deposition rate of deposition, we have to control that. If it is like some rapid deposition, then you will see the pore pressure will rise more. Then presence of fine tailing layers, again not only the high discharge rate, soft sand beads. You can see that the first one, soft sand beads. That's why I am focusing, you should have a beach. Do not allow the beach to come close to the dam. Then the presence of fine layers, beneath the new dam. So you can see that when we go to the next section, normally that's why close to the dam we are putting the coarse material, not the fine material. But that didn't happen. They found that these are some of these materials are not coarse, they are fine. Then the slip surface initiation within the fine tailing layer during operation and construction. Their model is showing during the construction small things started, and those like layers, like initially they start, but gradually they progress. Those are the slip surface. They gradually progress, and due to creep and other triggers. Other triggers means definitely the water is again coming into it, because they do not have much provision of the good drainage system. The water is coming into it, and in this dam I have read that constantly people have already seen seepage before the failure. The people who visited, they are always seeing the seepage there. And then you can see once the whole thing joined, progressed, and a global slip surface generated, then it fell. So this kind of gradual, to me, looks like that is really happening most of the times. It gradually takes, and if you, so the key is here, can we detect this failure? Can you detect this like movement, or they are saying it's a creep, like very slowly moving. It was very slowly moving. So can we detect it prior to failure, and we can do some remedial measures. Next, we go to this Mount Poly, and you can see that there was a lake. I think the main factor why it was highlighted a lot, there was a lake in there. And that lake was a big issue. And it was, you can see that it is very close to the tailings, and once it fell, everything went to those lakes. So this is also a latest one, 2022. It came out. I always review, go through these new things are coming. And this is again for the Mount Poly from the very beginning, like when the expert committee what they said, and everybody, a lot of research I have seen, everybody agrees to that same thing. So here you can see, I will focus on two things. You see that whole, like so many things here, but you see that this is a glacial till deposit in the bottom, in the foundation, but very thin. They call it upper GLU layer, glacial level upper glacial layer. Can you see that? Also in 3D they are highlighting. This is upper GLU, and in the here in the cross section you can see that there is very thin. They say it's hardly 3 feet. So, and in whole this, it's a downstream kind of construction they are doing when they are raising this. So this is whole rock here, and they think that rock field will protect the hill. But all the people, they agreed that whole thing fell because of this small layer liquefied and fell. So what the rock field is doing here? So the cause of failure, here you can see foundation failure. So here is the issue is the foundation, and that is they call it glacial lake deposit layer known as upper GLU, where the strength is, the layer was found to be weaker and less resistant to shearing than anticipated, particularly under on-drain conditions. The failure resulted, yesterday we were talking about whether rotational or translational. It's a combined rotational and translational, leading to sudden breach of the dam and release things. Investigator revealed that because a lot of research has gone here, in the design of the dam they missed that, because it was very thin. If you go back again, it was a very thin, this one very thin and not everywhere. So when you are doing the borings, maybe they missed it. So this was not considered in the design. That's what the investigators are saying. The design also lacked sufficient consideration of the potential for on-drained failure. Okay? So the Mount Poly changed whole design. After Mount Poly, the norm becomes the on-drain. That's the reason people also switched from limit equilibrium model to numerical model. Because if you consider on-drain shear strength, it's very difficult to get 1.5 factor of safety. So that's forced the people, so limit equilibrium is not giving you anything. But limit equilibrium still you can use it. But the 1.5 factor of safety you won't get it. So now let us do the numerical model. Again, numerical model is the solution. Because some these kind of failure, like the failure which occur, you cannot get that in limit equilibrium model. The limit equilibrium model will not show you, because limit equilibrium model, you are giving that strength. That's fixed. In the finite element model, that strength can change. And it will show us whether it is liquefying or not liquefying. Why they cannot? So this made the norm that you have to do that. Again, the failure already we have discussed is went to the lake, and then the lot of remediation effort was needed. Some simple concept I think we have already mentioned. Continue. Okay, some simple concept like how this on-drained behavior is mostly related to the brittle, which is contractive. Like earlier we showed in the CPT, how can you differentiate between contractive soil or dilated soil? So it has to be contractive soil, and you can see that from peak, SU ratio can be 0.35, but in the residual it can be like minimum we have seen like 0.05 in some cases. So when it liquefy, there is no strength, same soil, it can have 0.35 you start with, but when you go there you do that. That's why the alert, I think yesterday we say that. So that is what is the risk probability? This is coming under the risk, how we see. So if the probability 10 to the power minus 3 to 10 to the power minus 4, that gives definitely the caution, like you are not good. But if it is lower than like 10 to the power minus 6, there is low probability that it will happen. So that's a good. That's why this alarm is here. And here you can see like where what exactly the alarm, like that green circle, which is called like a sweet circle. The name is sweet, it's very good. So you can see that your risk will decrease with the cost. You have to, because right now you are not doing anything, so you are thinking it is a very low cost. Very low cost, but under low cost you are taking very high risk. That will go back, like they are 10 to the power minus 3. Now we do good thing, it lowers. Then all the effort, resource and effort also will like increase the cost. Like when you do proper investigation, you do proper modeling, you do everything, cost will increase. So that is the point, like that is kind of acceptable. This is where it is acceptable. The risk is low, cost is also little bit higher. We are not saying you spend like a lot of things. So that's where you select, that's the point they say is the alarm. Again, that's why after human we have the GIST. So you can see how they are all linked. So we have a, like any company, they have a board, because the board of governors of the company, if there will be anything, they are responsible. Like so a lot of companies go bankrupt and immediately they have to change their board of governors and anything happens. And then the CEO. But there should be a one person which is the, what GISTM says, will be accountable executive. So that accountable executive is connected to higher management and also all the operation and everybody. So this executive is now connected to everybody. The training facility operator, the engineer in charge, like you guys are the RTFE. All your role is mostly acting RTFE. Unless you are like UR, because UR is mostly the consultant. And UR is like just one person, but again, that company, the consulting company, which our UR, we all support. So it's a company responsibility also. So though you are in one person, but there is a whole group of people, they work with you. And then again the design engineer, they are also consultants, and important also in the GISTM, you should have a TPA, that is third party review. You should have a third party review. And also you should have a IT admin. So this is called dam safety report, which you should have every 3 years, and ITRP every 5 years. So these two review are most. So that's why. Then the contractor. So the contractor, whenever he does anything, like you guys, somebody said that, oh, we are designing good, but contractor is not doing good. No. You have to monitor it. You have to send a person there to make sure contractor follows the design. Again, little bit I am putting some risk analysis, those are coming. You have to identify, first you have to identify the risk, then identify the failure modes, like what will be the probable failure, then estimate the consequences. That's where the analysis comes. So you derive the profile, then you go to the risk evaluation. You identify the risk, do the analysis and evaluate it. That alarm is alarm met, because we are focusing on the alarm. We should be good point there, like your risk is low and cost is not that high, like beneficial, but what the main thing is, we have the low risk. So these are done in every stages. This is I am showing like there were some questions like what should be a typical sleep cycle. So in the upstream, you can see that you have to go a little bit beyond the last one. And it will come out a little bit beyond the doors. Because mainly if you have a very strong foundation, you can ignore that. But if your foundation is not strong, then you should go into the foundation, definitely. You should go into the foundation. Again, another alternative also, if you have coarse grain, because you can see these are all coarse grain, we also see that my sleep circle is going through the time, because time where it will start. Again, the upstream, what are the risks in the upstream? Because we are mostly focusing on the upstream, because that's the lot of people are still is going on. So, insufficient strength of tailings to support new construction. So when you start raising, then you have to see that where you put it, your foundation. Is that good? Excess pore pressure, you have to monitor those pore pressures. Limited water tightness, again coming to the dam. The dam should be watertight, water resistant, and make sure that water cannot encroach through it. So that's the dam you have to focus. Not like just I am going to another way, just whatever I want, I will just go there. No, that one is protecting everything. And mostly that's why we want it to be drained and contained. Drain is very close to the drain because we don't want water to enter into the dams. But again, whatever you do in tailings is very difficult to make sure that everything will be fine. So that's why monitor, put piezometers. Again, the liquefaction, whether the cyclic loading or static loading, we already discussed. So check the liquefaction. Monitoring. I am saying the monitoring. I showed this one also in the INSAR. So right now, INSAR becoming the norm. People are doing that. So you can see that in bromine failure, prior to like we are seeing nothing is happening, but suddenly we see it's moving. So that's why they say that it's the creep. The creep is the first. So you have to again look at this data and then get. So finally, like I will not go much detail into that, but this will be a tailings dam monitoring system which is coming now. So it doesn't start at the end. This you see this. If you see this one, this diagram, it starts from the very beginning in the level 1. When we start the project. Level 2, you go to the construction. Level 3, you go for the monitoring. Again, level 4, it will give you the early warning. Like when we put any monitoring system, you should have a threshold value. And that threshold value will give you the early warning. And once you get the early warning, then you should have a decision support. Like there should be taking that early warning, you should come up with what kind of decision you should take. That's the management. At the same time, you can see that you have the social and community people are also involved. You are also getting their comments or their opinions. And all this thing is counted here. And finally, when I end, this diagram you have to take in your mind. So you have these people here, they are all responsible for design of L014 system, not only design, operation, construction and closure. So with that I end hold our talk here, and I hope you all should get like at least the good concept, and you can take this knowledge and try to use in your site. Like now you can go back to your site, look into your things and see like, oh, I learned this, I know this one, let us see that my site is following this or not. With that I end this 5 days of things, and I definitely thanks IIT Dhanbad and the Professor Das to give me opportunity to come here and interact with you. It was a very good time for me. I really liked it, and really I liked your enthusiasm. I saw that you all are very good. And you are very good engineers. And only thing like little bit we have to follow what is showing, and also you can continue your study, like you know like what to do. Here I can mention that this latest ICOL version is 194, which is still under draft. It has not been finalized, but that's the much better document than rest of the things what I have seen. They have clearly shown a lot of technical things also in that ICOL things. I am not giving you the directly this because this is still under draft stage. But definitely this year final thing will be published. With that I end my talk. Thank you.
Thank you, sir. So, do we have any questions? This is the last lecture, so I invite you to if you have any question, this is your last chance. After that, you can interact with sir also. Do we have any questions? We should have some.
In that the sleep circle failure in upstream slide which you had shown, yeah, this one, sir. So here, as you said that we have to cover the larger area for the sleep circle. What is that reason, sir? Like why the larger area is?
Because the critical is whole dam is failing. That's the most critical. Because small failure you can see, but you have to make sure that the whole dam is not failing. So that's why that's the critical.
So in that, sir, we are not covering the slime part, sir.
Again, that's why I am saying. Again, depending on what you see there in your site. But in your site, if you see that the slime is very close to the dam, then you should consider slime.
Slime as well. So here the slime is quite far away. That's why we
No,
have almost.
yeah, the
not
slime
covered.
is quite far away, but that's why it says the alternative. So you can see both. When you do the analyze, you can see both and then see like it, depending on what is the strength of the slime and what we consider.
And sir, I think here you have tried to cover the base failure also because the circle is going below the foundation level also.
That always we want in case, only case like if it's a rock foundation.
In rock foundation?
In rock foundation, normally we don't go below.
Below,
Because
yeah.
we know that's a rock.
Yeah.
It will not go there.
Yeah, it will not fail.
But
Correct, sir.
if it is not rocks, it's a must. You should see entering into the foundation.
Foundation, base failure also we have to.
Exactly. Yeah.
That's it.
Okay, so thank you. So, I think we don't have any questions. We will move ahead with the closed session.